In today's dynamic and evolving digital terrain, the need for robust cybersecurity measures has never been more critical. As technology continues to advance, hackers are constantly adapting their methods, making it imperative for ethical hackers to stay one step ahead. This course explores the convergence of ethical hacking and generative AI, specifically focusing on the scanning and enumeration phase of ethical hacking. I'll explore the network scanning phase in the ethical hacking process and how generative AI and prompt engineering enhance this process. With a solid foundation, I'll then explore ways that prompt engineering can optimize scanning, the risks and benefits of using AI-assisted scanning, how generative AI can boost various scanning techniques, and finally, I'll examine realistic examples involving scanning and enumeration techniques, focusing on the role that generative AI plays in these scenarios. This video explores network scanning and enumeration and focuses on how generative AI and prompt engineering enhance these processes. Okay, so network scanning and enumeration are integral steps in ethical hacking. Network scanning involves probing a network to identify active hosts, their services, and the respective open ports. Enumeration, on the other hand, dives deeper, extracting more detailed data about the network like user IDs, system roles, and shared resources, providing a hacker, ethical or otherwise, a comprehensive view of the system's vulnerabilities. With the advent of generative AI and the evolution of prompt engineering, these processes have become more precise and efficient. But how exactly do these technological advancements enhance network scanning and enumeration? Generative AI models leverage machine learning to generate new, original content by drawing on extensive training data. In network scanning, these AI models play a vital role by automating the creation of new scanning strategies that adapt to different network environments, enhancing the efficiency and effectiveness of the scan. For example, an AI model could be trained on various network scanning techniques, like ICOMP echo scanning, which uses ping commands to detect active hosts in a network based on their response to the ICOMP echo requests. There are TCP connect scanning, which completes the TCP three-way handshake to reliably determine open ports, although its transparency makes it easily detectable by intrusion detection systems. There's stealth scanning, also known as SYN scanning. This technique initiates but never completes the TCP handshake, making it less detectable as it doesn't leave standard logs on the target server. After learning these techniques, the AI can generate unique scanning strategies to optimally detect open ports and active hosts in different networks, even those with sophisticated network defense mechanisms. Essentially, the AI customizes the scanning process for each target network, significantly increasing the chances of identifying vulnerabilities. Okay, prompt engineering is a critical aspect of training generative AI models. It involves carefully crafting inputs, known as prompts, to guide the AI towards producing the desired outputs. With prompt engineering, AI models can be directed towards specific types of enumeration, including NetBIOS, SNMP, or LDAP enumeration, depending on the identified services during the scanning phase. By crafting carefully designed prompts, ethical hackers can guide the AI to extract specific details from the target network. For example, an engineered prompt could direct the AI to focus on identifying system roles in an LDAP enumeration, or to extract a list of user IDs in a Windows network through NetBIOS enumeration. Through this approach, the process of enumeration becomes more targeted and yields richer, more useful data. The integration of generative AI and prompt engineering in network scanning and enumeration has had a profound effect on ethical hacking. For example, an ethical hacker looking to identify vulnerabilities in a network might utilize an AI model trained on various scanning and enumeration techniques. During the scanning phase, the AI could generate a unique scanning strategy that combines, for example, TCP SYN scanning and UDP scanning to bypass the target network's firewalls. Upon identifying the active hosts and open ports, the hacker could then use prompt engineering to guide the AI's enumeration process. If the AI identifies an open port associated with the NetBIOS service, the hacker could craft a prompt that directs the AI to enumerate all the user IDs and shared resources on the network. The utilization of AI in this manner does not just speed up the process, it significantly increases the thoroughness of the scan and the enumeration. By leveraging the AI's machine learning capabilities, the hacker can unearth vulnerabilities that might have been missed through traditional methods, leading to a more secure network. Consider a scenario where an ethical hacker is tasked with conducting a security assessment on a complex corporate network. To start, they utilize an AI model trained on numerous scanning techniques. After an initial AI-powered network scan, the active hosts, open ports, and services running on them are identified. Let's say the AI identifies several hosts running an SNMP service. The ethical hacker would be well aware that SNMP is a protocol that, if not properly secured, can represent a vulnerability. Here's where the role of prompt engineering comes into play. The ethical hacker, aware of potential SNMP vulnerabilities, crafts a prompt specifically targeting SNMP enumeration. The prompt instructs the AI model to thoroughly enumerate SNMP data on the identified hosts, seeking information like the SNMP version, community strings, like passwords, and system information. The AI model, following the carefully engineered prompts, begins a meticulous SNMP enumeration process. It identifies that a few devices on the network are still using SNMP version 1, which is well known for its security vulnerabilities. Without prompt engineering, the AI model might have spread its focus too thin, possibly overlooking these crucial details. But with a well-crafted prompt, the AI was able to uncover specific vulnerabilities in the SNMP service. Okay, so network scanning and enumeration are key phases in the process of ethical hacking. While cybersecurity threats continue to evolve, leveraging cutting-edge technologies like generative AI and prompt engineering helps organizations stay one step ahead of potential cyber threats. By effectively integrating AI and prompt engineering into the ethical hacking process, scanning and enumeration strategies can be automated and optimized, ultimately resulting in safer and more resilient networks. This video explores how generative AI can streamline and augment scanning and enumeration in ethical hacking. Organizations of all sizes recognize the importance of cybersecurity. A key tool in safeguarding organizations' digital assets and sensitive information is ethical hacking, which is simply the practice of probing systems to uncover and address vulnerabilities proactively. By leveraging the power of generative AI, ethical hackers can significantly enhance and streamline the use of various tools for scanning and enumeration, augmenting their efficacy and efficiency. Generative AI excels at creating new data models from existing ones. It learns the underlying patterns in data, generates novel data instances, and offers significant automation and augmentation capabilities. In ethical hacking, generative AI can dynamically learn from existing patterns in network structures, vulnerabilities, and exploits, then generate innovative strategies for more efficient vulnerability scanning and enumeration. In ethical hacking, the scanning phase involves examining systems for potential weaknesses. Tools like Nmap and Nessus are widely used to scan open ports, services, and detect vulnerabilities. However, the vastness and complexities of modern network infrastructures and the growing sophistication of potential threats make manual scanning highly challenging. Generative AI can help overcome this challenge. By learning patterns in network structures and vulnerabilities, a generative AI model can automate and optimize scanning operations. This saves time, money, and resources. For example, AI can identify patterns in how certain vulnerabilities appear in network systems, and then tailor the scanning process to focus on areas where these vulnerabilities are most likely to appear. Consider, a hypothetical AI-powered scanner might learn that systems running a specific version of an operating system often have a certain open port. The AI could then prioritize scanning for this port in similar systems, streamlining the scanning process by focusing on the most probable vulnerabilities. This ability to learn and adapt makes generative AI a powerful tool for scanning operations. Okay, so enumeration is a process that provides a more detailed view of target systems, extracting active usernames, system banners, or network shared resources. Common tools such as SMB enum and SNMP walk are commonly used for enumeration. Applying generative AI to enumeration could have a transformative effect. By learning from previous enumeration operations, AI can predict the most productive paths for enumeration and suggest an optimized approach. It can even suggest alternative strategies when initial attempts do not yield the desired results. Consider a situation where an ethical hacker is trying to enumerate a system with a tool like SMB enum. The process is time-consuming and depends to a large degree on trial and error. However, a generative AI system could analyze historical enumeration data and suggest more effective enumeration strategies. It could indicate that SMB services on servers running a specific version of Windows are usually configured in a certain way, thereby narrowing down the enumeration strategy. A concrete example of generative AI's potential lies in the Deep Exploit tool. Deep Exploit leverages machine learning to predict the success rates of various exploits, significantly streamlining the vulnerability scanning and enumeration process. By learning from previous operations, it can focus on high probability targets, saving time and increasing success rates. Another example is the DARPA-hosted event Cyber Grand Challenge, where AI systems were tasked with finding and patching vulnerabilities in a mock network. The winner, Mayhem, used a form of generative AI to create novel strategies for detecting and mitigating vulnerabilities, outperforming competitors and demonstrating the potential of generative AI in ethical hacking. So overall, as ethical hacking evolves, the integration of generative AI in tools for scanning and enumeration is inevitable. It offers the promise of more efficient, effective, and targeted ethical hacking equipped to deal with the growing complexity of today's digital landscape. By embracing this technology, ethical hackers can stay one step ahead of their malicious counterparts, safeguarding digital assets. As business continues to rely more and more on digital systems, the combination of generative AI and ethical hacking will become increasingly important for robust cybersecurity. This video explores some of the ways in which prompt engineering techniques can optimize scanning strategies and output. Prompt engineering techniques can significantly optimize scanning strategies and output in various natural language processing tasks. A few ways in which prompt engineering can be more effective is by using domain-specific phrasing, instructional clarity, contextual framing, progressive prompting, controlled output constraints, and iterative refinement. These techniques help optimize scanning strategies, generated output, and contextual responses. So what are they exactly? Domain-specific phrasing helps optimize scanning strategies and output because by using domain-specific language, it enhances the relevance by aligning the model with the context. Domain-specific phrasing also helps in targeted search for accurate, tailored information, and domain-specific phrasing maintains output style aligning with domain conventions, which serves to enhance the output's usability and its overall acceptance. Instructional clarity helps facilitate effective scanning by firstly providing a more efficient scanning process. Effective instructions help prompt engineers quickly identify relevant details, allowing them to extract crucial information efficiently and discard irrelevant details. Clear instructions guide prompt engineers, aligning their thinking with desired outcomes. Precise objectives and specifications eliminate ambiguity, ensuring accurate and contextually appropriate output generation. Contextual framing in prompt engineering empowers models to generate more accurate, coherent, and contextually appropriate responses while reducing biases and improving overall efficiency. By providing context, framing helps models identify and prioritize relevant details, enabling them to produce more accurate and targeted responses. Contextual framing assists in mitigating biases by providing explicit instructions to models, encouraging fair and unbiased generation of responses. By considering the broader context, models can generate responses that align with the flow of the conversation or narrative, resulting in more coherent and engaging output. Framing prompts with specific instructions also helps models to produce desired output with greater precision, minimizing irrelevant or off-topic responses. There's improved clarity. Contextual framing allows models to understand prompts better, capturing nuances and subtle cues that aid in generating more contextually appropriate and coherent outputs. Contextual framing also has an effect on adaptability. By incorporating context, models can adapt to various scenarios, switching between different contexts and generating output that is tailored to specific requirements. And finally, there's optimized efficiency. Contextual framing enables more efficient scanning of information, allowing models to focus on relevant aspects and reducing the computational burden, resulting in faster response times. Now, progressive prompting enables step-by-step response generation for enhanced context understanding. This results in more accurate and relevant outputs through iterative refinement of information and questions. Designing structured prompts allows control of desired results, aligning intentions with generated outputs. Progressive prompting also helps fine-tune scanning strategies. It breaks down complex tasks into smaller subtasks for efficient information retrieval, reducing computations, improving speed and accuracy. And progressive prompting empowers engineers to guide model output. Designing structured prompts allows control of the desired results, aligning intentions with the generated outputs. Controlled output constraints can also play a key role in optimizing scanning strategies and output. By incorporating controlled output constraints, prompt engineering ensures that the generated output aligns with the desired objectives and specifications. This helps narrow down the focus of the model and improve the relevance of the generated content. Controlled output constraints also serve as safeguards against biased or undesirable outputs. By defining specific constraints, prompt engineers can prevent the model from generating content that may be offensive, inaccurate, or unethical, leading to more responsible and reliable results. And finally, iterative refinement helps by facilitating continuous improvement and fine-tuning of generated text. Through iterative refinement, scanning strategies can be iteratively adjusted and honed, allowing for the identification and elimination of errors, inaccuracies, and irrelevant information in the generated text. By refining the prompts iteratively, it becomes possible to tailor the generated output more closely to the desired goals, ensuring greater relevance and alignment with the intended context and requirements. Iterative refinement enables the detection and correction of inconsistencies and logical gaps in the generated text, leading to improved coherence and flow of information, making the output more coherent and understandable. And through repeated iterations, scanning strategies and prompt engineering can be fine-tuned to maximize the desired output quality, optimizing factors like readability, accuracy, language style, and other specific requirements. In this demo, we'll perform a scan while leveraging generative AI. Okay, to get started in my demo, I've opened my browser and I've navigated to nmap.org/download.html #Windows. I'm here because we want to install Nmap on Windows. So on this page, locate latest stable release self-installer, select the link, and in the downloads dialog that appears, just select save. And that will save the self-installer to your download directory or whatever your default directory is for your downloads with your browser. Okay, so now that's done. Now on the second tab, I've navigated to pypi.org/project/python-nmap. And we're here because we need to install the Python nmap library, and that'll help us use the nmap port scanner with our Python code. Now we install that with Python pip package manager by typing pip install python-nmap. So we don't need to download anything from this page specifically. Okay, so down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Okay, so I have a Python script named enhanced-nmap-scanning.py open. We'll look at this code shortly. But down in terminal, first I want to highlight the fact that we need to install Python-nmap, and to do that, we can just type pip install python-nmap. Now I've already done this, so when I press enter and it runs, it's going to say that the requirement is already satisfied, and yes, it does. Okay, so Python nmap is definitely installed on this system. Now the self-installer was in the downloads directory, so I'll just go down to the taskbar. I'll select Explorer. I'll go to my downloads directory, and there's the nmap self-installer. Now to install nmap, you simply run the executable. When the user account control dialog appears, select yes, and then just follow all the default settings. Don't change anything, just click next, next, install, and then once it's finished, nmap will be installed. We'll have the nmap Python module installed, and we'll be ready to start working with nmap in our Python code. Okay, so I'll just click next, next, finish, and done. You may need to restart Visual Studio Code if you have Visual Studio Code open. I don't have to because I've already installed both of these. If I type nmap right now, I get a response, and that tells me that nmap is definitely installed. Okay, so now let's look at this code. All right, so lines 2 through 4, I import the Python modules I need. There's a new one now, nmap. Then on line 7, I get the OpenAI API key from my environment variable. Line 10 is the function definition, and the function's name is active_recon_analysis. We've already been through these parameters in previous videos, so I won't go through those again. Okay, next, we initialize a new nmap object. I name it nm, that's on line 23, and I equate that to nmap.portscanner. So that initializes a new nmap object. Next, on line 26, I actually perform the scan. I'm performing a scan here for open ports on the 192.168.100.0/24 subnet. And what we do is we pass the name of the hosts that we want to scan, and I'm just, again, specifying the subnet and the arguments, and the only argument I'm specifying here is --open, so that's going to scan for open ports. Next, on line 28, I initialize an empty string for the output. Then, from lines 31 down through 37, I'm essentially iterating through the scan results, and I'm selecting the hosts, the open ports, and their status. Next, on line 40, I specify an F string named recon_query. Now, this is essentially the engineered prompt that's going to be passed to the AI model when I make the call to active_recon_analysis. And speaking of which, on line 45, that's exactly what we're doing. So I equate recon_analysis with the results from the call to active_recon_analysis, and I'm passing in recon_query. And again, that's the engineered prompt that we specified starting on line 40. Next, I generate the outputs for the enhanced scan report. And this report provides an overview of the scan, the query prompt, and the insights obtained from the scan analysis. I'm including the query prompt because I want to see exactly what was submitted to the AI model. And then I simply print out the insights. Okay, so now let's go down into terminal. First, I'll clear the terminal, and now I'll run enhanced-nmap-scanning.py by typing Python enhanced-nmap-scanning.py, and I'll use tab to autocomplete and press enter. This may take you a few seconds. I'm going to fast forward through this though. All right, let's explore this output. So there's the title, Enhanced Scan Report, and then the following is the recon query F string. Okay, so the F string starts with given the following network reconnaissance information, and then it lists all the reconnaissance information that was gathered using the nmap command, right? So that is what's going to be submitted to the AI model, along with the last sentence, please use this information to provide insights for the scan. Below that, I have insights from the enhanced scan, and it tells me that the host at 100.1 has several open ports that may indicate the presence of a web server as well as other services. In actuality, that's my router. The host at 100.129 has several open ports that indicate the presence of a Windows server, including RDP. The host at 100.134 has several open ports that may indicate the presence of a MySQL database server. So it was able to grab that kind of insight simply from the ports that are running on those individual hosts. All right, well, with that, we performed a scan leveraging generative AI. This video explores how information quality is affected by AI-assisted scanning. Cybersecurity is experiencing a revolution of sorts due to the convergence of artificial intelligence and ethical hacking. In essence, AI and machine learning are equipping ethical hackers with a robust toolkit that enhances the quality and the effectiveness of their hacking efforts. AI is potentially transformative in ethical hacking with AI-assisted scanning and enumeration. It facilitates the generation of enriched, accurate, and nuanced information, thereby escalating the effectiveness of the overall process. So, what exactly is AI-assisted scanning? Well, AI-assisted scanning refers to using AI algorithms to identify vulnerabilities within a network or system. This automated, intelligent approach not only improves vulnerability detection, but also aids in surfacing potentially unnoticed security gaps. Generative AI can exponentially improve the quality of information by creating multiple simulation scenarios based on the initial scan's data. Generative AI models like Generative Pre-trained Transformers or GPTs can generate human-like text based on the data input. They understand the context of the information and its various nuances and predict the next possible inputs. Generative AI can generate possible threat scenarios based on identified vulnerabilities. It can anticipate and simulate various attack vectors, potential security breaches, or data leaks that may occur in real-world scenarios. These models can understand the complexity of different vulnerabilities and create detailed, context-aware reports. Enumerating or cataloging the information obtained from AI-assisted scans is very important. The traditional methods of enumeration can be slow and might miss out on some vulnerabilities or connections. AI significantly expedites this process by enabling automated network enumeration and understanding the underlying patterns of the identified vulnerabilities. However, it's not just the scanning and enumeration that benefit from the integration of generative AI. The evaluation of obtained information also receives a significant boost, since ethical hackers can leverage AI-enhanced information to analyze and mitigate potential threats more effectively. Typically, ethical hackers follow a systematic process to data from scans. They need to understand the identified vulnerabilities, the potential damage they can cause, and how they can be exploited. AI-generated information, characterized by its depth and detail, can provide a clearer and more comprehensive view of the system's vulnerabilities. The detailed threat scenarios and reports make it easier for ethical hackers to understand the system's security landscape and prioritize vulnerabilities based on their severity. Additionally, generative AI helps in evaluating the risk associated with each vulnerability. Ethical hackers can use AI-based risk scores that use machine learning algorithms to rank vulnerabilities based on various factors, like the ease of exploitation, their potential impact, and whether it's been previously exploited. The enriched information allows ethical hackers to develop a robust remediation plan. AI's predictive capabilities can also suggest potential solutions or countermeasures for each vulnerability. This could include patching, system configuration changes, or the implementation of additional security measures. Overall, generative AI is helping revolutionize cybersecurity, and in the context of our discussion, it's proving to be a game changer in AI-assisted scanning and enumeration. It enhances the quality of the information obtained, enabling ethical hackers to carry out their tasks with unprecedented precision and efficiency. While AI in ethical hacking is a burgeoning field, it promises to reshape the future of cybersecurity, making it more proactive, precise, and insightful. This video explores how the same AI-informed measures that are used to safeguard networks can also be leveraged by malicious actors. While AI-informed measures can be highly effective in safeguarding networks and enhancing cybersecurity, they can also be leveraged by malicious actors to their advantage. Here are 6 ways that the same AI-informed measures can be used by cybercriminals: through AI-powered malware, through automated attacks, adversarial machine learning, AI-powered phishing attacks, evasion of intrusion detection systems, and AI-driven social engineering. Organizations and security professionals must be aware of these potential threats and develop robust defense mechanisms that account for the malicious use of AI. This includes continuously improving AI-based security systems, staying updated on the latest attack techniques, and employing a multi-layered defense approach that combines AI with human expertise to detect and respond to emerging threats effectively. Okay, well, let's explore in some detail how these AI-informed measures can be used by malicious actors. First, AI-powered malware. AI-powered malware is malicious software that leverages AI techniques to autonomously adapt, evade detection, and exploit vulnerabilities in computer systems. How does AI-powered malware defy network safeguards? One way is through camouflaged adaptation. AI-powered malware adapts and evades detection by blending in and continuously learning, making it hard to identify. It bypasses safeguards, remaining undetected for long periods of time. It uses intelligent evasion techniques. AI-powered malware eludes defenses by analyzing protocols, mimicking traffic, and exploiting weaknesses in real time. It has the potential to render conventional security ineffective. And AI-powered malware automates propagation and persistence, rapidly spreading and exploiting networks. It autonomously targets, exploits, and self-propagates, overwhelming defenses with coordinated attacks. Okay, then there's automated attacks. Despite their intended purpose of safeguarding networks, they can also be utilized for malicious activities. First, by weaponizing botnets. Automated attacks utilize botnets, which are networks of hacked computers, to launch dedicated denial-of-service attacks, overwhelming servers, disrupting services, and causing financial losses. Another automated attack type is credential stuffing. Automated attacks can exploit weak authentication by rapidly testing stolen or guest credentials, gaining unauthorized access to user accounts, and compromising sensitive information. While automated attacks were originally developed to enhance network security, their misuse highlights the need for robust defense mechanisms to counteract these threats effectively. Adversarial machine learning exploits vulnerabilities in AI systems, undermining their intended security measures. So, how does adversarial machine learning exploit vulnerabilities in AI systems? First, consider poisoning attacks. Adversarial machine learning injects malicious data into AI systems, corrupting the model's training process. The compromised model then makes incorrect decisions or exhibits unexpected behavior in real-world scenarios. Then there's model extraction. Adversarial machine learning allows attackers to steal AI models by analyzing their responses, reconstructing similar models, and exploiting them for malicious purposes, undermining proprietary algorithm development efforts. And finally, by evasion attacks. Adversarial machine learning deceives AI models by crafting malicious inputs, exploiting weaknesses in algorithms to manipulate data and evade network defenses. This leads to misclassifications and inaccurate threat detection. AI-powered phishing attacks undermine the intended purpose of AI-informed measures in a number of ways. First, with sophisticated manipulation. AI can be used to craft highly convincing phishing emails by analyzing vast amounts of data, including personal information and online behavior, making them harder to detect. Attackers leverage AI algorithms to constantly evolve and adapt phishing tactics, bypassing traditional security systems and increasing the success rate of their attacks. Then there's personalized targeting. AI enables attackers to create targeted phishing campaigns based on individuals' preferences, interests, and behavior, making the attacks appear more genuine and increasing the likelihood of success. And automating attacks. AI automates various stages of phishing attacks, including email generation, malicious link insertion, and response analysis, allowing attackers to scale their operations and launch multiple attacks simultaneously. Then there's the evasion of intrusion detection systems. Intruders can exploit vulnerabilities in AI algorithms used by intrusion detection systems, bypassing their detection mechanisms and compromising network security, rendering the AI algorithms essentially ineffective. Evading intrusion detection systems can also hamper threat intelligence. Evasion techniques limit the amount of accurate data available to train AI models, which reduces the ability to learn and adapt to emerging threats, thus weakening network defenses. Now, similar to phishing attacks is AI-driven social engineering. Malicious actors exploit AI algorithms for AI-driven social engineering by profiling victims. AI analyzes vast amounts of data to identify victims' preferences, behaviors, and vulnerabilities. AI can generate personalized messages or scenarios that exploit victims' trust, making them more likely to fall for scams or provide sensitive information. And AI leverages the insights gained to manipulate victims' emotions, build rapport, and deceive them into taking harmful actions, like clicking on malicious links or disclosing personal details. In this demo, we'll leverage generative AI for enumeration. Okay, to get started, I've opened Visual Studio Code, and I have a Python script named enhanced-nmap-enumeration.py open. Previously, I've performed a port scan on a private subnet. The scan showed me that there were several hosts that had open ports. Now, I'm going to go just a little bit deeper by enumerating so I can obtain more information about those hosts. And that's what I'm doing with my enhanced enumeration script. So let's explore the script. From lines 2 through 4, I import the modules that I need for this demo. Note that on line 4, I'm importing Nmap. That's the Python-Nmap library. And to install that, you just type pip install Python-Nmap. Okay, then on line 7, I grab my OpenAI API key from my environment variable that I set up. Line 10 is the function definition for active_recon_analysis. This function is going to use the OpenAI.completion.create method to interact with the GPT model. I'm not going to go through these parameters. I've already done that in previous demos. Okay, now scrolling down on line 23, I initialize a new Nmap object. On line 26, I'm performing an aggressive scan by calling nm.scan. So with the scan method, I pass the hosts, and in this case, it's just my private subnet 192.168.100.0/24, and the arguments -a. -a enables operating system and version detection. So that's what I mean. We want to go a little bit further from our basic port scanning to now where we are enumerating the operating system and version. -a also enables script scanning and traceroute. Okay, so then on line 28, I initialize an empty string to hold the output. Now lines 31 down through 41, I'm iterating through the scan results. I'm going to pull the host, the operating system, its name, how accurate the guess is, the open ports, and their status. That's recon_info. I'm going to pass that as part of my engineered prompt, and that occurs starting on line 44. So recon_query is essentially the engineered prompt. And on line 45 through 48, it says, given the following network reconnaissance information, and it includes all the reconnaissance info that I'm gathering with the Nmap scan, please use this information to provide insights for each host identified in the scan, focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then on line 51, I'm equating recon_analysis with the results of the output from the call to the active_recon_analysis function. I'm passing the function, the recon_query, that's again the engineered prompt that I designed starting on line 44. Then starting on line 55 to the end of the file is a report which just provides an overview of the scan. I'm also including the query prompt because I want to see everything that was submitted to the GPT model. I also print the insights obtained from the scan analysis. So down in terminal, I'll type Python and the name enhanced-nmap-enumeration, tab to autocomplete, and press enter. This can take a couple of minutes because it has to scan through all of the devices on the 192.168.100 subnet. I'm going to fast forward through, but again, just keep in mind that this can take upwards of a couple of minutes. All right, the script has completed and the report has been printed to the terminal. I'm just going to scroll up to the very top of the report. And the reason why I want to include the query string is because I want to see exactly what was submitted, again, to the GPT model. What was submitted, the entire engineered prompt, starts at given the following network reconnaissance information. Then it includes recon info, which is all the information gathered by the reconnaissance performed using the nmap command. Then to complete the prompt, please use this information to provide insights for each host identified in the scan, specifically focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then the end of the query string notification. Okay, and then below we have some insights. It tells us that 192.168.100.1 is most likely running Microsoft Windows 11 21H2, FreeBSD, or some other operating system, and it has 4 open ports. Interestingly, that is my router, so it's dead wrong here. 100.128 does not have any identified operating system or open ports. It's well protected. Host 129 is most likely running Microsoft Windows 7, Windows Server 2008, or 2008 R2, Windows 8, or Windows 8.1 Update 1. It also has a number of open ports. The fact that it's running such an old Windows operating system, the version information tells us that there may be some significant vulnerabilities there. Okay, so continuing on, and it tells us that 100.134 is most likely running Microsoft Windows 10 1607, and 100.2 is most likely running VMware Player, Virtual NAT device, and so on. We were able to take the reconnaissance information that we had based on the nmap scan, and we were able to analyze that using generative AI. This video explores the significance of generative AI and prompt engineering in optimizing scanning and enumeration. The significance of generative AI lies in its ability to revolutionize various fields, such as creative content generation, data augmentation, simulation, and others. It enables new possibilities, enhances efficiency, and drives innovation in these domains. Let's discuss the significance of generative AI and prompt engineering in optimizing scanning and enumeration. We'll explore how generative AI enhances efficiency, how it improves accuracy, how it enables scalability, how it adapts to evolving threats, and optimizes resources. Okay, so let's start by exploring how efficiency can be improved using generative AI and prompt engineering. Automated data generation gives diverse and realistic data sets for training and evaluating scanning and enumeration algorithms. Faster detection and analysis processes quickly generate synthetic data that cover a wide range of scenarios, and targeted prompts can be created. These tailored prompts guide the generative AI model's behavior, which reduces the need for manual filtering and post-processing. Next, improved accuracy using generative AI for scanning and enumeration. First, let's talk about robustness to variability. Algorithms are exposed to various edge cases and challenging scenarios, leading to improved accuracy in real-world applications. Synthetic data generation allows for the creation of synthetic data that closely resembles real-world data by training scanning and enumeration algorithms. Error reduction also improves accuracy, obviously. By training and fine-tuning the model based on feedback and evaluation, accuracy can be significantly enhanced, reducing false positives and false negatives in scanning and enumeration processes. And validation and verification. It's possible to validate the accuracy of algorithms against ground truth or expected outcomes. This enables a more reliable assessment of the accuracy and effectiveness of the scanning and enumeration techniques being employed. Next is scalability. Large-scale data generation allows for the efficient generation of large-scale data sets, which is critical for scalability in scanning and enumeration. Scalability makes it possible to cover a wide range of scenarios in testing and evaluation of scanning algorithms. Now, parallel processing allows for the simultaneous generation of multiple data points or prompts. This enhances scalability by leveraging the power of distributed computing, enabling faster and more efficient scanning and enumeration processes, particularly of large-scale complex networks. Then there's rapid iteration and adaptation to changing scanning and enumeration requirements. As the scale of data or complexity of scanning tasks increases, these techniques can quickly generate synthetic data or modify prompts to address evolving needs, and integration with distributed systems. So AI can be seamlessly integrated with distributed systems and cloud infrastructure. This integration enables the scalability of scanning and enumeration across multiple servers or cloud instances, allowing for the efficient allocation of computational resources and handling of large workloads. Next, there's the ability to adapt to evolving threats. Continuous learning means updating with new data to adapt to evolving threats. By incorporating the latest information and trends, AI models can generate synthetic data that reflects the current threat landscape, enabling scanning and enumeration algorithms to stay ahead of emerging vulnerabilities. Then there's prompt refinement. As new threats emerge, prompts can be adjusted to guide the generative AI model towards generating data that captures these new threats, ensuring that scanning and enumeration processes remain effective and relevant. By analyzing incoming data in real time, models can adapt to detect and respond to evolving threats promptly. This adaptability is essential in rapidly identifying and mitigating new vulnerabilities or attacks. Then there's the ability to transfer learning. This capability enables the adaptation of scanning and enumeration algorithms to new threats or scenarios with minimal retraining. This saves time and resources while maintaining a high level of accuracy. And collaboration. By sharing and refining prompts, best practices, and insights gained from generative AI models, the security community can collectively adapt to evolving threats. This collaborative approach enables a more comprehensive understanding of emerging risks and fosters the development of effective scanning and enumeration strategies. And lastly, generative AI and prompt engineering used in scanning and enumeration can optimize resource utilization. Synthetic data generation, for example, reduces reliance on real-world datasets that may be limited or expensive to obtain. This optimization conserves resources by leveraging synthetic data that closely resembles real data for training and evaluating scanning and enumeration algorithms. Prompt engineering techniques enable the creation of tailored prompts that guide the generative AI model's behavior. By designing effective prompts in this way, the need for manual data filtering, pre-processing, and post-processing can be minimized. So in essence, reducing manual effort. Then there's efficient resource allocation. AI techniques offer flexibility in resource allocation during scanning and enumeration tasks. By adjusting parameters such as batch size or parallelization level, the computational resources, including memory and processing power, can be optimized based on the available hardware or infrastructure. AI techniques can also streamline the scanning and enumeration process by generating targeted data or prompts that focus on specific areas of interest. This targeted approach eliminates unnecessary computations and reduces resource wastage, allowing for more efficient and optimized processing. And finally, scalable infrastructure. AI can be implemented in scalable infrastructure, such as cloud platforms or distributed systems. This scalability ensures that computational resources can be allocated dynamically based on the workload and requirements of the scanning and enumeration tasks. By leveraging the scalability of the infrastructure, resource optimization can be achieved by scaling up or down as needed. This video explores how scanning techniques can be improved with generative AI. Okay, so we know that scanning is a primary phase in the hacking process, and organizations and individuals use various scanning techniques to identify vulnerabilities and potential threats in their network infrastructure. When scanning is integrated with generative AI, the result is enhanced scanning capabilities and efficiency. Let's explore 3 key scanning techniques and how they can be improved or enhanced with generative AI. We'll look at port scanning, where a target system's open ports are probed to identify services and potential entry points. network scanning, which involves exploring the structure and characteristics of a network, like IP addresses, connected devices, and network topology. And vulnerability scanning. This is focused on identifying vulnerabilities and weaknesses in software, systems, or applications proactively. Okay, so let's move on and discuss how generative AI can enhance each of these scanning techniques. Okay, so how can generative AI enhance port scanning? Well, with intelligent scanning patterns, where AI is used to develop intelligent scanning patterns that adapt to target systems, and stealthy scanning. This is where the AI can assist in developing stealthy scanning techniques that minimize the footprint of port scanning activities. First, intelligent port scanning patterns. These can enhance the effectiveness of port scanning by first identifying hidden services. AI algorithms can find these hidden services and obscure ports that traditional scanning techniques might miss by analyzing response data from various ports. AI models can learn from scan results and adjust their scanning patterns, potentially optimizing the process by focusing on ports likely to have vulnerabilities or valuable services. So that's adaptive scanning. They can recognize evasive techniques. AI can learn to detect evasion techniques like port knocking or decoy services and adjust scanning patterns to reveal them. And overall, they improve accuracy and efficiency. AI algorithms can dynamically adjust scanning speed, prioritize ports based on vulnerability likelihood, and intelligently manage the process, reducing false positives and improving the scanning's overall effectiveness. Stealthy port scanning techniques using generative AI can result in more covert port scanning activities, enhancing the effectiveness of vulnerability assessments and providing organizations with a better understanding of potential security risks. They do this with adaptive scanning, where the AI analyzes port responses, learning to identify hidden or obscure ports. There's smart scanning speed, where the AI adjusts scanning speed, taking into consideration network traffic and system behavior, making activities blend seamlessly, making them less detectable. And prioritizing scanning. AI can rank ports by vulnerability potential, scanning high-risk ports first, saving time and improving stealth by quickly pinpointing critical entry points. Okay, now enhanced network scanning. Generative AI can enhance network scanning by using autonomous discovery, where AI algorithms are trained to autonomously discover network devices and their relationships. And generative AI can also facilitate anomaly detection in network scanning. All right, autonomous discovery. AI algorithms can analyze network traffic patterns, protocols, and behaviors to autonomously map and discover devices, even those that are not actively responding to traditional scanning techniques. This enables a more comprehensive and accurate network inventory, including previously unknown or hidden devices. AI can learn and recognize patterns indicative of potential security threats, like stealthy malware or advanced persistent threats. By autonomously analyzing network data, AI algorithms can identify suspicious activities or anomalies that may go unnoticed by traditional scanning methods. AI-based autonomous discovery can also adapt and scale according to the dynamic nature of complex modern networks. It can continually learn and update its knowledge base to accommodate new devices, services, and vulnerabilities, so that network scanning techniques remain effective in rapidly evolving network environments. Okay, so generative AI anomaly detection can enhance network scanning techniques by, first of all, enhancing detection accuracy. AI models can learn normal patterns of network behavior by analyzing vast amounts of network traffic data. This allows them to accurately identify anomalies that may go unnoticed by traditional rule-based approaches or signature-based detection systems. Generative AI can also help with early threat detection. Generative AI anomaly detection can identify these emerging threats or zero-day attacks by recognizing deviations from expected normal network behavior. The result can be reduced false positives. Traditional anomaly detection systems often generate a large number of false positives, which can lead to alert fatigue and waste valuable resources. AI models can help reduce false positives by providing a more accurate understanding of what constitutes abnormal behavior. AI models, we know, can adapt to evolving network environments. and they can learn from new patterns or threats. As the network evolves, the anomaly detection system can update its understanding of what constitutes normal behavior, improving its accuracy over time. How can generative AI enhance vulnerability scanning? Well, by intelligent scanning and prioritization, by patch prediction and recommendation, and with exploit simulation, where generative AI simulates real-world exploits and attacks on target systems. Okay, so first let's look at intelligent scanning and prioritization. AI-powered algorithms quickly identify vulnerabilities in large-scale systems, applications, or networks, which results in saving time and effort. Now, with intelligent scanning, AI algorithms simulate attack scenarios and proactively explore potential vulnerabilities, providing comprehensive coverage and reducing potential blind spots. They can prioritize risks. AI analyzes and ranks vulnerabilities based on their severity, potential impact, and exploitability. This makes it easier for security teams to prioritize remediation efforts effectively. And as we've come to understand, generative AI continuously learns from new vulnerabilities and evolving attack patterns, which improves its accuracy and effectiveness of future scans and prioritization. Okay, so now let's look at how generative AI can enhance vulnerability scanning through exploit simulation. Generative AI can automatically generate realistic exploit scenarios, allowing for a broader and more comprehensive coverage of vulnerabilities during scanning. There's adaptive learning. We know that AI algorithms can learn from previous exploit simulations and improve their understanding of vulnerabilities, enabling more accurate identification and prioritization of potential risks. And there's realistic testing. By simulating actual attack scenarios, generative AI helps validate the effectiveness of security measures and allows for proactive mitigation of vulnerabilities before they can be exploited by real attackers. And lastly, patch prediction and recommendation. Vulnerability scanning can be improved through patch prediction and recommendation by AI, because generative AI algorithms can analyze past vulnerability patches to identify patterns and trends. Based on the analysis, AI models generate predictions for potential vulnerabilities that may arise. The AI systems provide recommendations for specific patches or mitigation strategies to address identified vulnerabilities. By leveraging generative AI, vulnerability scanning techniques become more proactive, enabling organizations to stay ahead of potential threats and strengthen their overall security posture. This video explores case studies involving scanning and enumeration techniques with a focus on the role of generative AI in these real-world scenarios. Generative AI models, like GPT-3 and 4, have proven their ability to generate human-like text, create designs, and even write code. Ethical hackers can employ these same AI models to automate and improve their hacking techniques. A common example cited is using AI to automatically generate phishing emails or messages that are more likely to deceive users. If you're familiar with ChatGPT, for example, you understand how creative and concise it can be. Well, one way it enhances scanning and enumeration is by automating the process. This makes it faster and more accurate. Further, the generative AI can be trained to identify potential vulnerabilities and subsequently recommend the best course of action. Okay, let's explore a couple case studies and highlight how AI-based scanning and enumeration can be used to enhance the hacking process. So case study 1, the Mirai botnet attack. The Mirai botnet attack in 2016 can be analyzed in the context of scanning and enumeration. Hackers created a botnet of IoT devices by continuously scanning the internet for IoT devices and then attempting to log in using a list of common default usernames and passwords. In this case, the scanning phase was essential for finding potential targets, and the enumeration process involved attempting to log into the devices. AI could potentially have been used by hackers to optimize the scanning process or even to enhance login attempts by predicting common username and password combinations. Okay, case study 2, the 2017 Equifax data breach. In the 2017 Equifax data breach, hackers exploited a vulnerability in the Apache Struts web application software. The hackers could have used scanning to identify systems running the vulnerable software. Enumeration would then involve understanding the architecture of Equifax systems, identifying where valuable data was stored. A generative AI model could have potentially accelerated the process by automating the identification of systems running the vulnerable software and suggesting subsequent steps for the attackers. Being able to analyze case studies and past events is a critical skill for ethical hackers. Here's why. For one, studying real-world cases helps ethical hackers understand the strategies, the tools, and the techniques used by attackers. It also provides insights into how organizations respond to security incidents, providing lessons on what works and what doesn't work. It can also be used to help anticipate threats. By analyzing past events, ethical hackers can identify patterns and trends in cybersecurity threats, which can help them understand, anticipate, and prepare for similar future hacking attempts. Case studies can also provide the basis for ethical hackers to refine their strategies. They can assess the effectiveness of different hacking techniques and evaluate defense strategies, incorporating this knowledge and the lessons learned into their practice. Analyzing case studies can help ethical hackers understand the potential impact of security breaches on organizations, emphasizing the importance of robust cybersecurity measures. Recognizing the impact of breaches can also provide a motivating factor for ethical hackers to continually enhance and refine their skills and knowledge. Therefore, the ability to analyze case studies is an essential skill for anyone involved in ethical hacking because it's part of continuous learning and improvement in this rapidly evolving field. Okay, with that, let's wrap this course up by considering a possible framework for analyzing ethical hacking case studies. First, understand the background. Grasp the context of the case, including targeted systems, the type of attack, and its impact. Identify the tools and techniques. This involves identifying the specific scanning and enumeration tools and techniques used in the attack. Consider the role of AI. Examine if and how AI was employed in the hacking process, or if it could have helped prevent the attack. Evaluate the response. Assess the timeliness and effectiveness of the organization's response to the attack, and then suggest improved ethical hacking and security strategies based on the analysis. And finally, apply lessons learned. Extrapolate the insights gained to inform future ethical hacking efforts and security strategies. So in this course, we've examined how generative AI and prompt engineering are utilized in the scanning phase of the ethical hacking process. We did this by exploring network scanning and enumeration, and combining scanning tools with generative AI and prompt engineering to optimize scanning. We explored information quality and AI-assisted scanning, AI-informed measures and risk of exploitation, and leveraging generative AI for enumeration. We explored the significance of generative AI in scanning and enumeration, improving scanning and enumeration techniques, and we explored and briefly analyzed some relevant case studies. In our next course, we'll move on to explore prompt engineering and generative AI with system hacking concepts.